All right, so this will be a presentation of the project solution that I came up with for creating a hyperconverged network solution for the 3 atmospheric science departments of the colleges. All right, so we are presenting the solution hyperconverged network for atmospheric science departments of Texas A&M, Penn State, and the University of Wisconsin. We've created a hyperconverged compute and storage network solution for this, and the proposal that we're going to be presenting will show the proof of concept for this solution that's been crafted to address the networking and data storage and processing needs of these 3 atmospheric sciences departments. We're going to present a virtualized platform to provide storage as well as computation of large sets of data for these departments, as well as LAN and WAN solutions to service both locally and interdepartmentally. So the 30,000-foot view of the project will have 3 separate campuses, all utilizing the same design. The proposal is going to present a unified design for all 3 major elements needed to address the project. Those 3 elements are going to be a hyperconverged compute storage solution, a campus LAN, as well as a WAN system to interconnect those 3 campuses. The hyperconverged compute storage solution that we'll be providing is going to be 3 host devices. Those are going to be loaded with ESXi and then will be virtually clustered inside of vSphere. We'll have 2 storage services that will servers that will service them. Those are going to be loaded with Ubuntu Server, and they are going to be housing the distributed eDEX that the VMs sitting in vSphere will be utilizing. To manage all that, we will have an instance of vCenter, and that will be the hypervisor for those ESXi instances. And then we'll also provide the virtual distributed switch, which will provide routing in between the hosts and servers, as well as the LAN network. That distributed switch is going to provide management, ISCSI targeting of those data stores, as well as vMotion and high availability functionality between those clusters. This will be a layout of the topology for that cluster. We'll have a couple parts. So your physical layer basically here, it's going to be comprised of those 3 ESXi instances on some bare metal servers. And those will be linked through the switch stack that will be servicing this to those 2 Ubuntu data stores. The vSphere will be laid over top of those 3 ESXis. They will be clustered within that. We'll have vCenter running on that to be the hypervisor and manage, and then we'll have VM instances of the Cave client that is utilized for this processing of weather data. This will be a diagram of the virtually distributed switch that will be created within vCenter and will service this. This will have 7 different port groups, each with dedicated links to 2 NIC cards per host, and those NIC cards will be wired across the 2 switches in a redundant manner to provide failover in case of loss of connectivity of either of those switches. The VM kernel port groups will provide management, vMotion, access to the LAN, and then 2 dedicated ISCI targets for each of the Ubuntu's data stores. This will give failover redundancy and also provide the opportunity for load balancing between these devices. So the next portion will be the campus LAN. The campus LAN is going to be comprised of 5 portions. We'll have a server switch stack, which will be servicing the server cluster. It's going to be comprised of 2 48-port stackable switches. They're going to be stacked and servicing that hyperconverged server cluster. The other portion will be client access. This is going to be provided by two 24-port switches. They will be servicing all local client devices, along with any of the other access needs the department may have, whether that be for wireless access, perhaps a guest network, whatever they may need. The next section will be a collapsed core switching group. That's going to be comprised of two layer 3 24-port switches. We're going to configure those with VRRP, and they will service both core and distribution needs for the LAN. The final portion of that will be campus edge devices, and those campus edge devices will be two routing devices. They're going to provide edge connectivity to the leased lines that we'll have between each of those campuses. And then the final portion will be a network management server. The network management server will be a platform to house an ISP firewall for the connection to the ISP. Additionally, it will provide a platform for any SDN software that is implemented down the road, and also service any DHCP needs that the LAN may have. So this is just a combined layer 1 and 2 topology of the LAN. It'll have a couple different pieces. This is that switch stack that will be servicing the vSphere server stack. Like we mentioned, it will be those two switches stacked together. They will be redundantly linked to this core and distribution switching group. Additionally, we will have these two separate access switches providing all of that access need for the local clients. We have the firewall, which is housed on that server, which will also potentially house any SDN software that we run at a later time. Our core and distribution collapsed core is going to be redundantly linked to those two edge routers, which will be connected to the two different campuses through leased lines. This is a layer 3 look at the topology. As you can see, we are representing the virtual representation of that collapsed core, which is using the VRRP. Additionally, we're also showing the logical representation of the switch stack, which is servicing vSphere. These will all be addressed with their own sub networks, and then also the networks between our routing devices. The next portion of this will be the WAN. The WAN is going to be comprised of 4 sections. We'll have those edge devices, which are those two routers that we talked about. We're going to have 2 routing devices, which will comprise the campus edge. They're going to provide redundant connectivity to their inter-campus leased lines. We will have dedicated lease lines between each of the campuses. They are going to provide dedicated throughput as well as inter-campus connectivity and redundancy. We're going to utilize a single area OSPF in this. The WAN's going to utilize that and will connect all routing devices within the 3 campuses. That's inclusive of those collapsed core switching groups, which will function as the first hop devices for the LAN. Finally, we're going to utilize GRE tunneling with IPsec as an overlay, and we'll use the tunneling to provide some private connections in between the campuses across those lease lines, and then we'll also do that IPsec overlay just to ensure that there is encryption of any data that is moving across any sort of public lines. All right, and this is just a diagram of the WAN topology. So you can see here your 2 edge devices, collapsed cores here for each of the campuses. Leased lines will be represented here, and then these will be our GRE tunnels that are pushed across this OSPF area, and we'll have that IPsec overlay on top of that. So we ran 3 test cases to show functionality and to verify that these configurations would work, and I'll run through those with you right now. So for the first test case, we did a live migration with vSphere vMotion. For that test case, we demonstrated the ability to live migrate a running VM with vSphere vMotion. To display this, we utilized vMotion and a shared data store, and we migrated a running VM, which is represented by TS01, which is Test Server 01, and we ran that across computational resources between two separate hosts. We did this while maintaining constant uptime of that VM, as well as connectivity through the network. The VM was migrated across. We maintained that network connection by pinging the VM throughout the course of the migration. The results of this test were successful. There was no loss of connection to the VM through the process, and there was confirmation through the vCenter logs that the VM was migrated successfully. So I'll show you a video of that demonstration now. So we show here the VM that we're moving, show the address of said VM. We're going to come over here and ping this address with a constant ping just to show connectivity throughout the duration of this migration. We'll move back over here and we'll perform the migration. So we'll go through a couple of different selections here. We are choosing to only migrate the computational resources of the VM. We're going to move it to ESX1 from ESX2. So we'll select that. There's some configurations for networking. We've kept this simple with just a single network connection for it. And then we're going to schedule vMotion with high priority so that it gets pushed through quickly. There's an option to do that with a little lower if you don't want to use up too much of your computational power to perform this. So the process is started. We'll swing over in just a moment and look to see that we do have this continued ping going on, connectivity, and we're about 40%. I am going to go ahead and move this forward a little bit because it did take a while to push through. The computer that I have this hosted on was running at basically maximum power, and so it took a little while for it to push this through. Apologies, it skipped forward. Let's jump back up here and we'll just show the completion of this. So we're still getting those pings. We're at 50%, 60, 70, and it should complete here in just a moment. Almost there. There we go. Okay. And it has completed, and then we can verify here that it has moved to the other host. All right. So for the second test case, we demonstrated VRRP and did a failover test on that collapsed core switching group. So for this test case, we demonstrated failover redundancy for VRRP protocol, and we're using that on that collapsed core switching group. To display this, we basically created a, within GNS3, 2 routing devices to represent that VRRP pair. We have access switches on either end of that, as well as hosts to push data across them. And then we're using 2 Wireshark instances on the outgoing ports of the VRRP devices to observe which of the devices is actually pushing through packets. We'll see that they are being pushed through the master device. We will fail over that master device, and then we will see the packets transition to what was formerly the backup and has subsequently become the master device in that VRRP pair, and Wireshark will capture this. The results of this test were successful, as we will demonstrate with this video. So I did run into a challenge with this with Wireshark shutting down when I shut off the device that it was attached to. So I incorporated a couple of hubs to create a break in the line such that the Wireshark instance would not be shut down when I shut down. So this is just indicating that switch 2 is the master of this group. and switch 1 is the backup of this group. And we do a VRRP on both the incoming and outgoing ports of these devices. So we'll be showing the Wireshark instances, and I will have to get a second one shut because it did shut down one of the Wireshark instances. So take just a moment, we'll get that put back up. Right, here we go. And then we'll filter for the ICMP packets. I'm going to pull up a terminal connected to the host device, and we're going to push through some pings. So we'll push through pings to the host device on the opposite side of this VRRP pair, and we'll just do a continuous ping across that so we can observe that. So these pings are pushing through, timed out for the first couple, but now we're good. Traffic's pushing across, and you can see that the traffic is being pushed across the master device, which is SW2. So we'll indicate that here. That's this one here. So we're going to fail this now. We will suspend this, and then we'll come back across and see the change. There'll be minimal packet loss. And now we can see that it is pushing through on the second device, which was formerly the backup and has now become the master. And then we'll double check to see that those pings are still pushing through, and looks like we only lost 2 in the process. That'll be your demonstration. We'll look here to see that switch 1 has switched from the backup to the master. And then, of course, switch 2 is shut down, so it's not going to indicate anything. And that is the end of that demonstration. So for the final test, we demonstrated the GRE tunneling and then did the IPsec encryption over top of that. For this test, we demonstrated the creation of GRE tunnels over the OSPF infrastructure, and then we did an IPsec overlay for encryption on that. We displayed this in GNS3 as well. We created a section of the WAN, used a grouping of routing devices, and then put together OSPF routing across those. Wireshark will be used to capture packets in the middle of that on what would be the equivalent of the leased line or public lines of that. The GRE tunnel is established between the 2 edge devices, and it is tunneled across that network, and then we do have that IPsec overlay. The results of this test were successful. We had a hiding of the origination and destination addresses, as well as encryption of the packets. So we'll go ahead and look at the video for that now. All right. So we've got our 4 devices. The CCs will represent your first hop devices. We've configured those, and we're going to send a ping across for the public address, just to show that that is demonstrating the public address. And then we will come back and we will ping on the private address, and we're going to have a successful ping across that, but it will still display the public addresses. Additionally, it's going to show that the protocol is ESP. It is encapsulated security payload, so these packets have been encrypted, demonstrating that the IPsec overlay was functional as well. And yeah. So as far as the solution, to present the scalability of the solution, we'll just talk a little bit about what the initial implementation will be, and then some potential future additions, improvements, or scaling of the solution. So V1, it's going to be the initial design and implementation of this LAN, WAN, and server stack that we've talked about. What I do foresee as being V11 would be the addition of an SDN overlay for those campus LANs to provide some better monitoring, some better security, and some better management of the network itself. Potentially V12 could be the migration of those localized clusters into a single cluster of resources, so all of the ESXIs from all three campuses being clustered together under a single vCenter instance, and then would provide some better utilization of resources. We could share across campuses and be able to do a little better utilization of that. Potentially version 2 could be the addition of a whole nother atmospheric sciences department from a different university. It would be very easy to overlay this same format to them with whatever upgrades we made in the interim. As far as vendors for this, for the server stack, we have tried to stay pretty vendor neutral, and so we'll make a selection based off of pricing. We have a couple of parameters that we're looking for the hardware for this. For the ESXi hosts, I'd like to have 8 cores, 128 gigs of RAM, and I'd like them each to have a 500 gig solid state drive. For the data stores, we need probably 4 cores. I think 32 gigs of RAM should be sufficient, and I'd like to start them with 4 10 terabyte SATA drives. For the LAN devices, I looked at a couple of different options, and it seems like Cisco is probably going to be our best bet. The Meraki line seemed like a really good option for potential upgrades in the future with their cloud managed services. If that was something, especially as this continues to expand, that we wanted to utilize, we would have devices that would be compatible for that. We're still evaluating the market for best solutions for WAN devices, but very likely we would utilize Cisco devices as well. So the final portion of this presentation will just talk a little bit about some of the challenges, reflections, and some of the lessons learned. So I'll switch over here. And the project has definitely presented quite a few challenges. I've discussed a fair amount of those with you already, but this was something that I definitely had never done before. I did not have any real experience in taking something this large and breaking it down. Agile methodology was something that I had never really utilized and really hadn't seen much about. So it was challenging initially to utilize that. Tools like Trello were something that I was not very familiar with. And so I feel like initially I was kind of more going through the motions of utilizing them, but I don't know that they were really functioning as being helpful per se. So, you know, it was something that I was not familiar with and not very comfortable with initially. As I progressed, I was definitely made aware of my shortcomings, both from a technical understanding standpoint, but also just from that organizational standpoint, having to work through 2-week sprints and really be focused in that manner. Was challenging for the first couple, but as we discussed, I feel like the third sprint was kind of a breakthrough sprint for me. I focused very much on putting together my vSphere instance, getting my ESXi instances put together, syncing those together. I spent a significant amount of time in that 2-week period working on those, and it was a lot of trial and error, but I did really utilize a lot of these agile principles through that, and they were incredibly helpful. I think they provided an opportunity for me to have a framework to really be focused, and when I kind of chased down rabbit holes, they provided an opportunity, or provided a framework rather, to corral that and really encouraged me to say, okay, this is a rabbit hole, it's time to stop and maybe move on and work on another aspect of this. The other major challenge for me was working on this individually. I had originally taken this class in the fall of last year and had chosen to not stay in that class with the intention of coming this summer so that I could take it in a group. I felt like being surrounded by some other people that might be able to help assist in some of the places where I'm maybe not as strong, and have more of that true team scenario. I felt like I would thrive a little better in that, and truthfully, I probably would have. But I actually am appreciative of the fact that I was able to do this on my own. There's a certain sense of pride in that, and I do feel like, I wasn't able to get quite as far along in the project as I probably would have liked, but I do feel like that there was some pretty discernible improvements throughout the course of the project, and I definitely learned a lot from that perspective. Um, from a reflection standpoint, like I said, I really enjoyed and felt like the process from start to finish was one that was challenging in a good way. There was a significant amount of stress involved in it, but I learned quite a bit. From a technical standpoint, I learned quite a bit about designing a network. It is definitely a lot. There is an insane amount of pieces that are involved in even something as small as what we put together. But it was really cool to kind of see all of that. I will say that in particular, working within vSphere and vCenter was really interesting for me, and that's something I think I probably will maybe work towards doing some certifications in at some point. I do think long term I could see going into some data management and maybe even working within some data center type roles, and could see that being incredibly useful. Additionally, I found, although I did not get into this very deeply, a lot of the SDN solutions, as well as some of the automation aspects of network maintenance and security, and all of those different aspects are really interesting to me. I definitely see that as being technology that's going to be utilized a lot more moving forward, and definitely something that would be very valuable to pursue some more exposure to. I think this last sprint was really good as well. I think that that it was where I felt the most comfortable. I think it was definitely still challenging. There was a lot of stress trying to get the tech spec put together. There's a lot of focus on that in that last sprint, and there was certainly still some trial and error. I found out pretty later on that I had initially picked a switch to use for my switch stack that is no longer serviced by Cisco. It's the one that you'll see in every example, or at least every example that I look for. And towards the very end, just doing some research, I think I was looking at pricing on it, I found out that it was one that's no longer available. So little things like that, improved challenges, but I definitely felt like I was able to utilize some of the things that I learned in the previous sprints and really be efficient with my time in this last sprint. I started a job in the last sprint, so I've definitely had less time to be able to devote to the project itself, and I still feel like the last sprint was one that was probably as productive as any of the others that I did. Additionally, I will say that while working remote like this, there obviously was not a ton of interaction, both with you and with other students. In particular, using Microsoft Teams, which I will say I was somewhat proud of getting that set up. I felt that facilitating that was a good idea and something that was useful, especially for me, and then for particularly two other classmates of mine, George and Jason, both. Particularly in the last 3 weeks, we have spent a significant amount of time bouncing ideas off of each other, especially in this last week. We even just had mild therapy type sessions of kind of talking each other through pieces that we're working on, talking about how we're stressed out about trying to get things done. So being able to have that as a support mechanism throughout the course of the project was really helpful, and something I was very thankful for. And then conversations that I had with you, particularly the last one, was definitely very encouraging. It was very challenging initially, and I think that was by design. Obviously, you pushed back on questions and things that I posited, which was good because it made me dig a little bit deeper. And so I think things that maybe were frustrations at the beginning of the class evolved into understanding the reasoning behind them and actually being thankful for them because they did provide challenge and forced me to kind of do things and learn them on my own. Definitely wasn't perfect, and there's a lot of room for improvement, but it was a good challenge to kind of go through that process and to have to sort of be isolated like that and work through it. So as far as lessons learned, I think I learned a lot about being organized. I think I definitely would like to try and garner some more experience within the agile process. The other thing that I would like to maybe look a little bit more into is potentially taking some classes on project management. I think that would be something that'd be incredibly useful moving forward, just for personal projects or potentially for career goals moving forward. I think the dipping our toe into the agile process through this project has piqued some curiosity about that. So that's something that I will be looking into a little bit more. And then outside of that, overarching, I think just the kind of learning to work through challenging aspects, persevering. That sprint 3, there were. I probably spent I ran into the challenges of computer not working, finally got the computer that I could work on this on, and that was in the second week of that sprint. And so I spent that second week probably working about 45 hours on that portion of it. I was up all hours of night, and it was to the point where I was dreaming about this kind of stuff. So I really got emerged and really fully saturated with it, and that was really cool. I haven't done that with a technology before, and obviously still had a lot to learn, but it solidified my decision to come into this field, and it's kind of renewed an excitement about learning about these technologies and continuing. I'm going to be pursuing getting my CCNA after this, and so I'm pretty excited about going back and studying and kind of renewing my my understanding of those technologies and getting ready for that certification. And it's already got me thinking about what I'm going to pursue next as far as different things. I mentioned maybe doing some certification in VMware. I'd like to maybe do some project management certification. So I think there's a lot to be learned, and I learned a lot from the perspective of managing my time, being efficient with my time, and staying focused. But even more than that, I think I'm leaving this project with a renewed excitement for the career path that I've chosen. All things going according to plan, graduating after this and moving into a new career is pretty exciting. I've spent the last 15 years working in restaurants and bartending, and it's a pretty big deal, especially at my age, to be making a career change. And it's a little daunting, but I think this renewed an excitement for the decision that I made to do that and to pursue this. It's something that I really do enjoy, which is good to know since I'm going to be doing it for the foreseeable future. So, yeah. It's been a very challenging class. There's a lot that I did learn. There's probably a ton more that I could have learned, but I do feel really good about where I'm at 10 weeks down the road, and feel like I've learned a lot and taken a lot away from it. So I've enjoyed it. I've enjoyed the minimal interaction that we've had, and I'm appreciative of the help that you've offered. And yeah. I entered in with a lot of stress and anxiety and feeling pretty unsure. And while that's not entirely gone, it is lessened significantly. So that's pretty cool, pretty exciting. So I think that's the end for me. I'm going to sign off, and yeah, thank you very much.